3 billion years. That's how much time the TRAPPIST-1 system had before our sun even ignited. 3 billion years to birth oceans, to spark biochemistry, to build civilizations. It represents 75% of all star systems in the Milky Way, the most common arena for life in our galaxy. We aimed the James Webb Space Telescope at its two most promising worlds that should have won the cosmic lottery. The verdict? Bare rock. No thick atmosphere, nothing. The laws of physics may have written sterility into the most abundant stellar neighborhoods in existence. The baseline state of the universe is not life. It's a silent, thermally inert void. This is a head start on nothing. February 22nd, 2017. A press conference. A room full of cameras. A projection screen glowing with the promise of 7 worlds. For the first time in our brief, flickering existence, humanity looked at TRAPPIST-1 and believed it could save us. The images were beautiful. Artist renderings, not photographs, of temperate planets wrapped in hypothetical atmospheres. 3 of them, we were told, sat within the habitable zone, that narrow band of distance where water might pool on stone instead of boiling away into the void or freezing into monuments of ice. We named them. We cataloged them. We projected every desperate hope we carried onto those 7 distant specks of reflected light. This discovery was not spontaneous. It was the endpoint of a lineage stretching back 4 centuries. Galileo aimed his crude telescope at Jupiter's moons and shattered the illusion that Earth was the axis upon which all motion turned. Centuries later, Frank Drake constructed an equation, not to answer whether we were alone, but to formalize the question, to give our loneliness a mathematical structure. The Drake equation asked, how many civilizations exist in our galaxy capable of communication? It gave no answers, only variables, only the shape of our ignorance. And yet, we kept building. The Spitzer Space Telescope launched in 2003, an infrared eye designed to pierce through dust and distance. 14 years before the press conference, it detected the first architectural hints of TRAPPIST-1's system. Shadows crossing a faint red star. Dips in light that whispered of worlds in orbit. Spitzer was the foundation. The James Webb Space Telescope would be the cathedral. A $10 billion machine built to interrogate those shadows and determine if they held anything worth reaching for. Between 2017 and 2023, TRAPPIST-1 became a symbol, not just of discovery, but of need. We are a species that builds monuments to combat our own irrelevance. Pyramids, cathedrals, radio arrays pointed at the stars, transmitting messages into the silence and waiting for echoes that never return. SETI, the search for extraterrestrial intelligence, turned its instruments toward TRAPPIST-1, listening, searching for patterns in the noise, for proof that somewhere across 40 light-years of empty space, something else was also listening. We funded missions. We wrote papers. We convinced ourselves that this system, this one arrangement of rock and gravity, could justify our existence. Our species has walked this planet for approximately 300,000 years. We have been aware of TRAPPIST-1 for less than a decade. In the 10 billion year lifespan of that star, our entire history, from the first sharpened stone to the press conference in 2017, is a rounding error. A flicker of consciousness that appeared, observed, and will vanish long before TRAPPIST-1 dims. But for those few years, we allowed ourselves to hope. We looked at artist renderings of alien sunsets. We imagined oceans lapping against unfamiliar shores. We constructed elaborate fantasies where TRAPPIST-1e, the most Earth-like of the 7, held forests, storms, perhaps even eyes looking back at us. We needed it to mean something. Because if 7 worlds orbiting a red dwarf 40 light-years away could hold life, then perhaps we were not an accident. Perhaps the universe was not as indifferent as the math suggested. Perhaps isolation was not the permanent condition of intelligence. That hope, fragile and unfounded, was the architecture we built around TRAPPIST-1. Not from stone or steel, but from longing. And like all architecture, it would eventually be tested by reality. The photons that arrived at the James Webb Space Telescope on March 3, 2023, began their journey in 1982. They crossed 383 trillion kilometers of void, a distance so vast that our fastest spacecraft, Voyager 1, moving at 17 kilometers per second, would require 63,277 years to reach the origin point. 600 centuries. Longer than written language has existed. Longer than agriculture. Longer than the pyramids have stood multiplied by 10. The photons carried a message, not of hope, but of confirmation. TRAPPIST-1 is a star by technicality alone. At 0.0898 solar masses, it sits just above the minimum threshold to ignite hydrogen fusion in its core. Any smaller, any less mass, and it would be a failed star, a brown dwarf, radiating only the heat of its own gravitational collapse. It burns, but barely. Its luminosity is 0.000553 times that of our Sun. If you stood on the surface of TRAPPIST-1b at high noon, you would see only darkness. The star is an ember, dim, red, invisible to human eyes without instruments. And yet, for years, we believed. 7 planets, all Earth-sized, 3 in the habitable zone, the entire system compressed inside Mercury's orbit. A clockwork mechanism wound so tight that years there last hours here. A star system built like a music box, every world a spinning gear in perfect resonance. Then the verdicts arrived. TRAPPIST-1b, dayside temperature 503 Kelvin. The measurement is sterile in its precision. The numbers tell a story without embellishment. The planet absorbs 100% of incident radiation. No atmosphere to scatter light, no clouds to cast shadow, no blanket of gas to soften the star's infrared pulse. The surface is bare rock, locked in tidal synchronization, one face forever burning, the other forever frozen. A coin spinning on its edge in the dark, with both sides dead. TRAPPIST-1c. The spectroscopy was unambiguous. No thick carbon dioxide atmosphere. The pattern begins. Not one barren world, but a sequence, a cascade, like dominoes falling in a row too long to see the end of. The photons traveled for 40 years to deliver silence. We built the Webb telescope to see back to the first stars, to witness the universe in its infancy. Instead, we turned it toward TRAPPIST-1 and saw the future, not of that system, but of inquiry itself. Each observation is a door closing, each spectrum a confirmation of absence. The telemetry does not lie, it does not comfort, it simply reports nothing is there. And the clock ticks forward, and the photons continue to arrive, and the message does not change. There are laws, not the laws we write, the laws written into the fabric of reality before anything could live to read them. And these laws do not negotiate. Consider what happens when a planet forms too close to its star. Gravity, relentless, patient, begins to slow the planet's rotation. One face is pulled toward the light, the other is condemned to eternal darkness. This is tidal locking, not a rare accident, a mechanical certainty. One hemisphere becomes a blowtorch, the other a bath of liquid nitrogen. Between them, a thin ribbon of twilight where winds scream at velocities that would peel continents apart. There is no temperate zone. There is no refuge. There is only the physics of proximity executing its function without mercy. But it begins even earlier. Before a star like TRAPPIST-1 settles into its dim, red glow, before it becomes the cool star we measure from 40 light years away, it burns. Stellar models show M-dwarfs spend up to 1 billion years in a pre-main sequence phase. 1 billion years of chaos. 1 billion years burning hotter and brighter than their final, stable form. The TRAPPIST-1 planets were born inside this oven. Their oceans, if they ever had oceans, boiled into vapor. Their atmospheres were stripped, molecule by molecule, by a star that had not yet learned to be gentle. By the time TRAPPIST-1 cooled, the planets were already corpses. And even if, somehow, an atmosphere reformed, even if volcanic outgassing slowly rebuilt what was lost, the star remembers how to kill. M-dwarfs are magnetically volatile. TRAPPIST-1 unleashes superflares, torrents of X-rays and particle radiation that methodically scour its inner worlds. Not once, not occasionally, regularly. Any fragile skin of gas that tries to cling to these rocks is eroded again, and again, and again. Life is not given a chance. It is not given time. It is not given the basic architecture of stability required to begin. We search for signs of life 40 light years away. 40 light years. The Bootes void, a region of space 330 million light years in diameter, contains almost nothing. No galaxies, no stars, no light. The distance to TRAPPIST-1 is 0.00012% of the diameter of that void. Our entire local neighborhood, the Milky Way, Andromeda, the local group, is an anomaly. A brief clustering of matter in a universe defined by absolute, terrifying emptiness. And even here, in this rare pocket of density, the sterilization protocols run perfectly. The JWST result is not a failure. It is a successful measurement of the void. It is empirical proof that these natural, physics-mandated chambers, tidal locking, infant furnaces, radiation guns, work with perfect efficiency. The universe does not need to conspire against life. It simply needs to obey its own laws. And it does, without exception, without mercy. We've been asking the wrong question. For decades, the Fermi Paradox haunted us with silence. Where is everybody? Why do we see no cities of light scattered across the spiral arms? No transmissions, no megastructures, nothing. We searched for answers in catastrophe, nuclear annihilation, runaway AI, ecological collapse. We called it the Great Filter, a barrier so lethal that every civilization hits it and dies. We assumed it was ahead of us. But the TRAPPIST-1 data doesn't whisper a warning. It delivers a verdict. The filter isn't waiting in our future. It's already behind us, measured, quantified, and it is the dominant form of reality in this galaxy. Red dwarfs make up 75% of all stars in the Milky Way. Not a minority, not an outlier, the galactic standard. For every sun-like star, stable, luminous, kind, there are 3 red dwarfs, small, dim, and lethal to anything that tries to evolve in their shadow. TRAPPIST-1 is not an anomaly, it is the template. And that template is a 3-stage execution. First, tidal locking. Planets so close they show the same face to their star forever. One hemisphere cooked under perpetual radiation, the other frozen in eternal night. Atmospheres stripped away like skin peeling from bone. No rotation, no day-night cycle, no buffer. Second, early luminosity. These stars are born bright and violent. For the first billion years of a planet's existence, the star scorches it with radiation levels that sterilize oceans before they can form, before amino acids can link, before anything resembling chemistry has a chance. Third, stellar flaring. Even after the star calms, it erupts. Flares so powerful they blast away what little atmosphere survives. X-rays and ultraviolet radiation carving through any molecular structure brave enough to assemble itself. It's not one failure, it's a physics-mandated cascade. Think of it like this. Imagine trying to build a house of cards inside a room where the air pressure randomly spikes every few minutes. The cards don't fall because you're unlucky. They fall because the room was designed to destroy them. 75% of the galaxy is that room. The Fermi Paradox asks, where is everybody? The TRAPPIST-1 data answers, they never began. Because 3 out of every 4 star systems are environments where complexity is preemptively shredded by the physics of stellar evolution. The silence we observe in the cosmos is not a mystery. It is the statistically expected outcome. Our sun, a G-type star, makes up less than 10% of the stellar population. Stable, long-lived, far enough from its planets that they can rotate, calm enough that life had 4 billion years to fail and try again. We are not the norm. We are the profound exception in a galaxy overwhelmingly hostile to anything more complex than ionized gas. And here's the cruelest realization. We've been searching for biosignatures, for technosignatures, for alien intelligence. We built telescopes and algorithms. We scanned the skies. We assumed the universe was full of potential. But we weren't looking for a needle in a haystack. We were looking for a needle in a universe of needles, all of them designed to preemptively destroy the thread before it could be spun. The Great Filter is not a single catastrophic event. It is not nuclear war or climate death or AI gone rogue. It is just statistics. It is the cold, indifferent distribution of stellar mass and orbital mechanics across 100 billion stars. Most of them killers. Most of them incapable of nurturing the slow, fragile process that turns molecules into minds. We exist, not because the universe is kind, but because we won a lottery we didn't know we were playing. And the ticket was printed 75% blank. The data is in. Mainstream science has accepted it, not because it wanted to, but because it had no other choice. The James Webb Space Telescope stared into the abyss of LHS 475b, and the abyss stared back with nothing. The debate now is not about whether this world could harbor life. That question died the moment the transmission spectra came back flat. The debate, if you can call it that, is about the precise mechanism of its inhabitability. How exactly is this planet dead? One hypothesis suggests the dayside temperature is slightly lower than what a perfect bare rock model would predict, a fraction of a percent cooler. This is not a sign of hope. This is not evidence of clouds or wind or water vapor softening the blow of stellar radiation. This is the observation that a furnace might be burning at 999 degrees instead of 1000. The corpse is still a corpse. Yet, because this is what we do, scientists began to speculate. Perhaps there exists an impossibly tenuous atmosphere. Perhaps heavy gases, sulfur dioxide, carbon dioxide, byproducts of ancient volcanism, cling to the surface in a film so thin it barely qualifies as air. Perhaps this ghost of an atmosphere provides a microscopic amount of heat redistribution, enough to shave a degree or two off the dayside inferno, enough to register on our instruments. This is the scientific equivalent of debating whether a body is at room temperature or 1,000th of a degree cooler. The subject is still dead. The details do not resurrect it. They merely describe the color of the coffin. And yet we continue. We took the most powerful infrared observatory humanity has ever built, an instrument designed to peer back to the birth of the cosmos, and we are using it to argue over the finest details of desolation. We are spending telescope time, computational power, and entire careers to measure the exact shade of black on a world that will never see rain. This is not science at its boldest. This is science at its most desperately human. A refusal to accept the simplest answer. A coping mechanism dressed in the language of rigor. We parse the data. We run simulations. We write papers debating trace gas abundances on a world where nothing breathes, where nothing ever could, because the alternative, the honest answer, is unbearable. There is nothing there, no atmosphere worth naming, no chemistry worth cataloging, no hope worth clinging to, just rock and heat and silence. And we cannot accept that. We cannot let the story end with a null result. So we invent subplots. We search for nuance in the void. We frame the absence of data as a mystery to be solved, rather than a truth to be acknowledged. This is not a search for life. This is a search for a rounding error in the equation of emptiness. We are cartographers of nothing, drawing borders on a map where no borders exist, measuring wind speeds on a world with no wind, calculating temperature gradients across a surface that knows only one state, uninhabitable. And we do this not because it will change the outcome, but because the act of debating keeps us from confronting the conclusion. The universe does not owe us complexity. It does not owe us mystery. Sometimes, most of the time, the answer is simple. There is nothing there. And 13 light-years away, LHS 475b continues its orbit, unaware that it has become the subject of our most elaborate denial. A world that exists only to remind us that proximity means nothing, that Earth size means nothing, that the universe is not obligated to provide us with neighbors, or even with interesting ways to be alone. The debate continues. The planet does not care.